In this video, we're going to talk about breaking a vector down into its components. So if you have a vector A, like the vector pictured here, its component vectors are called A sub x and A sub y. The A sub x is the x component vector. It's always on the x-axis. It's also called the horizontal component. And you have your y component that's always on the y-axis. That's also called your vertical component. And if you take the two component vectors, ax and ay, and add them together, you get your original vector A back. If we look at this and try to justify why that's the case, which method would apply here? Well, since the initial points of both vectors are put together, and you can see that this was turned into a parallelogram, this would be the parallelogram method. What we want to do is look at this picture here and try to figure out, can we find the magnitude, which is the length of the x component and of the y component. We're going to need a little more information here though. So we'll need the length of vector A and we'll need an angle. So we're going to suppose that this angle here, and this would be given to you, is 62 degrees. And that the length or the magnitude of vector A is the length or the magnitude of vector A is 7.25. Okay, so just from the trig that we've learned previously, this is definitely something possible for us to find. So we want AX. We know that this length here is 7.25, right? The length of vector A. Then, working off of the angle, this would be the adjacent side and this would be the hypotenuse. So, would it be the case that cosine of 62 degrees would have to equal AX divided by 7.25, right? And then if we solve for AX, we're just going to multiply both sides by 7.25. Okay, so we end up with our x component length is 7.25 times cosine of 62 degrees. We can approximate this. So you type this into the calculator, and if you do that, take the time to follow along and type this in, you should get about 3.4. Okay, so that's, the length of this is 3.4. Now how could we find the length of the y component? Well, this length is the same as this length, right? So we're kind of looking for this side here, which is opposite of our 62 degree angle, and we have the hypotenuse. So we would use sine. So it would have to be the case that sine of 62 degrees would have to equal the length of the y component, because that's opposite, divided by hypotenuse, which is 7.25. Alrighty, now we're going to multiply both sides by 7.25 and solve it just like we did the last problem. So we get that our y component, if we multiply 7.25 times sine of 62 degrees, we're going to get 6.4 approximately. Alright, so we have it. That's our y component, that's our x component. Alright, in general, there are rules for this. So if you're ever asked to find these components, you can just use set formulas. So I'll write those out. So in general, if theta is in standard position. Right, so that's a clockwise rotation, or I'm sorry, counterclockwise rotation is what I meant to say. Counterclockwise rotation from the positive x-axis. Then your x component is always going to be found by taking the length of vector A multiplied by cos theta, and your y component will be the length of vector A multiplied by sine theta. Alright, so this is, I'm going to make a note where A is the length, which is the magnitude, of vector A. So to distinguish between these, I'm going to put the vector symbol above that. So these formulas are going to be important to know. Okay, and they're super easy to apply. So I'm going to do a couple examples down here to show you how to apply these formulas. If we're asked to find the horizontal and vertical components, that's saying find the x and y components of the vectors in the given figures. Now we can just apply these formulas directly. First thing you want to ask yourself is this angle in standard position? So do we see this angle measured from the positive x-axis going counterclockwise? Yes, right? So we can just plug in to our formulas. A being the length. Did I forget to put that down? Okay, so we're going to assume the magnitude of the vectors is 750 in both cases. Okay, so if that's the length of this vector, then we're going to have 750 times cosine of 242.3. And then you're going to enter that into your calculator, and you should get approximately negative 348.6. Okay, and then to find the y component, we take, again, the length of the vector, which is 750, and this time multiply it by sine of our angle in standard position, which is 242.3 again. Type this into your calculator, and you'll get approximately negative 664. So notice that these values can be negative, and actually that's saying that the component vector AX, right, is going in the, is on the negative x-axis, and the component vector AY would be also on the negative y-axis. Okay, so these signs should always correspond to whatever quadrant the vector's in, right? X and Y are both negative in quadrant 3, so those answers are both negative. And one more. First question, right, we ask ourselves is this the angle from standard position? So from the positive x-axis going counterclockwise? It's not, right? This is only this a little angle here. What we really want to do is find the angle wrapped around like that. So what would that be? Well, the part we were missing was like actually 270 degrees, right? That goes from here to here, and we have to add 50 onto it. So if we take 270 and add 50 onto it, we're going to be at 320 degrees. Okay, so we're going to base this off of 320 degrees when we use the formulas. So our x component would be 750, cosine of 320. And our y component would be 750 sine of 320. And we'll approximate these. I don't have these answers written down, so I'm going to grab my calculator and we'll type this in. So we're working in degrees for this, so you want to make sure that your calculator mode is set to be in degrees. Okay, so I switched mine over to degree. Gonna enter this in. 750 times cosine of 320 degrees. We get 574.5 approximately. And then 750 times sine of 320, we get negative 482. 0.1 approximately. You want to check at the end, make sure this seems to be making sense. In the fourth quadrant, the x component would be positive, right? Because the x values are positive. Y component would be negative because y values are negative in that quadrant. Also, the numbers that you get, right, ignoring the signs, should be smaller than the length of the vector itself. Because if you turned it into a triangle, the x and y components would make up the legs of the triangle, and the vector itself would be the hypotenuse, so the hypotenuse always has to be the longest side, right? So that's another check, just to make sure that your answers make sense. Alrighty, that's it.